Hello dear students, this is your Giri Prasad. In the previous lecture, we have studied about the cause of motion. What is the cause of motion because of which the objects are moving? Yes, you are right. Force is the cause of motion. If you apply some force, the body moves. If you apply force, the body which is in motion comes to rest. If you apply some force, the body which is moving in a straight line can change its direction. Is it true always? Is it true always? For example, this is a wall, I am applying some force. Is it coming to motion? No. If a big crane is coming, if you apply some force, will it come to rest? No. Am I wrong? Do you think my statement was wrong? No, my statement is not wrong, but it's not complete. In the previous statement, I told what a force can do. I explained about the nature of force, its quality of force, it is its qualitative property. I explained about the qualitative property of the nature, but I didn't explain or discuss about the quantity. I didn't explain about the quantity, how much force is required to move this wall, how much force is required to stop the bulldozer, how much force is required to lift the object. In this lecture, we are going to discuss about the quantitative nature of the force. Before discussing that, we need to study about the objects. If you take any object, if it is at rest, it has no velocity, it has mass only. It has mass only. But if I throw it like this, it has two parameters. It has mass as well as velocity. The body has mass. Even in the motion, it has mass. When it is in motion, it has velocity. That's why whenever you describe about the object when it is under motion, we have to state its mass as well as velocity. Hence, by joining these two, we can explain about its mass and velocity with a single physical quantity, that is momentum. That is momentum. What is momentum? Mass and velocity. The description of the body with the help of mass and velocity is known as momentum. When the body is in motion, it has mass and velocity, which is known as its momentum. The momentum numerically given by momentum is equal to the product of mass and velocity. The product of mass and velocity is known as momentum. What are its units? Unit of mass is kg and the unit of velocity is meter per second. These are SI unit. What about CGS unit? Mass, grams, velocity, centimeter per second. These are our CGS unit, gram centimeter per second. Now let us see what happens when the body is in motion. Can this momentum be constant or can this momentum be changed? What happens if the momentum is changed, or what can change the momentum? Like these things we are going to discuss today. A body is described by its momentum, which is equal to mass into velocity. If the mass of the body is increased, momentum can be increased. Or by keeping the mass of the body, if the velocity of the body is increased, the momentum will be increased. Or by decreasing the mass of the body, keeping the velocity constant, momentum can be decreased. Or by keeping the mass of the body constant, if the velocity is decreased, momentum can be decreased. For example, This is a stone of mass 1 kg. This is another stone of mass 2 kg. This is another big stone of mass 3 kg. Which is moving with 1 meter per second? Moving with 1 meter per second? Moving with 1 meter per second. Now, what is its momentum? 1 into 1, 1 kg meter per second. Its momentum is 2 into 1, 2 kg meter per second. Its momentum is how much? 3 kg meter per second, like this. If this ball is moving like this, with this velocity, and with this velocity, if all these three hit a wall, and if they come to rest, for example, they stick to the wall, and they come to rest, what happens? Its velocity becomes 0. Its velocity becomes 0. Its velocity becomes 0. Means, what about its final momentum? Mass into velocity. Velocity is 0. So, final momentum is generally denoted by F, 0. Its final momentum is 0. Its final momentum is equal to 0. Initial momentum 1 kg meter per second, final 0. 2 kg meter per second, final 0. 3 kg meter per second, final 0. Now, what is the change in its momentum in all the cases? Here, 0 minus 1. The change is 1 kg meter per second. Here the change is 2 kg meter per second. Here the change is 3 kg meter per second. So, the change is different in different aspects. So, what happens if the change is more? What happens? Let me take one live example, then you can understand. For example, I am hitting you with this small stone with 1 meter per second speed, like this. I am hitting you with 2 kg stone, means bigger stone, with the same velocity. I am hitting you with a 3 kg meter per second stone with the same velocity, 3 meter, with the same velocity. Then velocities are same, the stone's masses are different. How do you feel? What happens to you? In which case you feel more pain? Obviously, in the third case, you feel more pain. Because, yes, you're right. In the third case, you have experienced more force. The stone applied more force on you in the third case when compared to the 2 other cases. Means, here what happened? The change in momentum is maximum. The force experienced is maximum. Here, the change in momentum is minimum. The force experienced by you is minimum. So, can I say that the force experienced is directly proportional to the change in momentum? The force experienced by you depends upon the change in momentum. And let us take one more example in which the stone is same, the velocities with which they hit you are different. Now let us see in which case you experience more painful, or in which case you apply for the stone applies more force on you. Let us see that. Of mass 1 kg, but you are throwing this stone with the different velocities. For example, 1 meter per second, the same stone, 2 meter per second, the same stone, 3 meter per second. So if I throw the stone on you with 1 meter per second, how do you feel? If I throw the same stone with a speed of 2 meter per second, like this, how do you feel? If I throw the same stone with 3 meter per second with much more velocity, like this, and it hits you here, how do you feel? In which case you experience more force? Yeah, obviously you can say this is because you got the pain. In the third case, you experience more force. So what happened here? What is the initial momentum? In this case, 1 into 1, that is equal to 1 kg meter per second. In the second case, it is 2 kg meter per second. In the third case, it is 3 kg meter per second. Imagine that it comes to rest after hitting you. So final momentum is 0 in all the cases. So what is the change in momentum here? 1 kg meter per second, 2 kg per second and 3 kg per second, in which case the change in momentum is maximum. In the third case, because the change in momentum is maximum here, that's why you have experienced more force. That's why we can say that the force is directly proportional to the change in momentum. And one more thing we need to discuss, that is there any relation between force and time? See, if the body can change its momentum in less time, you experience more force. And if the body changes its momentum in more time, you experience less force. For example, imagine that you are standing on the top of a building and you are jumping onto the sand and onto the concrete floor, in which case you experience more force. Exactly, when you jump on the concrete floor, you experience more force. But when you jump on the sand, you experience less force, because the time taken by you to come to rest is less in case of concrete floor, and it is more in case of sand. Means if the time is more, force experienced by you is less. If the time is less, force experienced by is more. Hence we can say that this force is inversely proportional to the time duration in which the body can change its momentum. Clubbing these two, we can write that F is proportional to delta P by T. So by removing this proportionality, we need to keep a constant, that is equal to K times delta P by T. In another example, I will derive the K value that leads to 1. So by placing it 1, what is our F? Is equal to delta P by T. Now see, we have arrived to one mathematical equation, that is F is equal to delta P by delta T, or T, or we can write it as a delta T. So which is nothing but the rate at which the momentum is changed is nothing but our force. These are Newton's second law. In the next class, we are going to discuss more about our Newton's second law. Today we have discussed about momentum and change in its momentum, and the relation between change in momentum and force, which leads to our Newton's second law. So today, try some problems based on our momentum. See you in the next lecture.